Here's your thought for the day. We're going to cover section 6.5 today. Using laws of trigonometry to solve geometry problems. Our objective is to use the law of sines and law of cosines to find the side lengths and angles in triangles. Oblique triangles, triangles that have no right angles. Oblique triangles, triangles with no right angles. When you have an oblique triangle, you're going to have to use law of sines or cosines or to solve it. So we've got for law of sines, it says that so it's these ratios. The sine of angle A over A will be the same as the sine of angle B over B, or the sine of angle C over C, or you can invert it. In fact, that's the way they do it in trig, so we'll use this form right here with the sides on top over the sine of the angle on the bottom. So those ratios are all the same. If I were to derive those ratios, here's how we do it. Okay, we've got the sine. What does the sine of A equal in this picture? The sine of A. What could we say the sine of A equals? Sine of A equals what in terms of letters? Shatise.
H divided by C.
Yeah, it equals H divided by C. So we have H equals C sine of A. Right? Sine of C equals what? Somebody else? Sine of C, what's it going to equal? Jordan? H over A. So, H equals A sine C. Right? And then we can set, so that since those both equal H, we can set them equal each other. We can say C as the sine of A is equal to A times the sine of C. Okay? And we want A and C on the top by themselves, right? So the next step would be to divide both sides of the equation. I'll go up here to the top by sine A times sine C. So we'd have C sine A over sine A sine C is equal to A sine C over sine A sine C. Then we cancel, and we're going to get, we cancel. No, I cancel. This would cancel. I canceled the wrong one there. It would be this one. So it would be C sine C equals A over sine of A. Alright? And you could do the same thing with B, right? Similarly, you know, we could say Also we can add to that, if we did the same type of calculation, we would have b over sine b. So that's the derivation of the law of sines. Now, do I have it? All right. So you're going to use the law of sines over the law. You have to decide whether you're going to use law of sines or law of cosines on a non-right triangle. You want to use law of sines if you can, because it's easier to do. And what you need to do is you look for a figure eight, what I call a figure eight relationship. Now you're only using this for non-right triangles. But so in this, what I mean by a figure eight relationship is I have a known side across from a known angle, like that. You make a figure eight, right? With that. So if I have that situation, a known side across from a known angle, I can use law of sines. So I'd set it up, and we would have the side 5 over the sine of 30 degrees is equal to the other side, a, over the sine of 45 degrees. Right? And then cross multiply and solve, we get a sine 30 degrees is equal to 5 sine 45 degrees. So then we have a equals 5 sine 45 over the sine of 30. You calculate that. Okay, make sure you put parentheses over the around the 5 times sine of 45. Otherwise, they'll just divide the sine of 45 by the sine of 30 and not the 5. You have to divide both of those by 30. And you should get, go ahead and practice the calculation. Make sure you get 7.07. Anybody not able to get 7.07? Everybody has it. Okay? All right. Here's an application. To estimate the height of a bridge over a stream, a hiker stands at point A on the bridge and measures the angle of depression to a rock to be 65. Okay, so you can see there the 65 is marked. Then she walks 50 feet to across the bridge to point B and measure the angle of depression of the same rock to be 42. Okay, so that's 42 degrees. How high is the bridge above the water? Alright, so we have to figure out the height of the bridge over the water. Alright, so to do that, how could I find the height of the bridge over the water? It's a two-step problem. Any ideas? Yeah.
First, draw like an altitude from sea to represent the height, and then like once you have that, you would have. Then you would. Never mind.
Okay, you're on the right track. We have to get this height, right? We have to get that height. But in order to get that height, I need to know one of these two sides. So let's find this side. We'll call this side A. Okay? I'm going to get rid of that height for a second so it's not cluttered up. Alright? To find A, How can we use the law of sines here? What can I use law of sines yet? What do I need to do? Zach?
You need to find the degree of C.
Yeah, we find the third angle. So, 180 minus 65 minus 42 is 73. 73 degrees. Right? So, there's my figure 8 with the 73 degrees. And now I can use that to find A. So to set it up, we'd have 50 over the sine of 73 degrees is equal to A over the sine of 65 degrees. Solve for A, so A equals 50 sine 65 degrees over the sine of 73 degrees. Right, so that's going to be approximately 47.39. Alright? So we've got A, now let's clear some of this out. We've got A now is 47.39. Now we can draw in the height. How am I going to find the height now? What am I going to do? Lord, Jordan.
The sine of 42.
Yeah. Let's draw the triangle separately. We've got this triangle. This is 42 degrees. And this length is 47.39. And we have to find the height. Right? So we do sine of 42 degrees equals the opposite h over 47.39. And so then we have h equals 47.39 times the sine of 42 degrees. So that's going to be approximately, what do you get? What do you get for your answer? Nearest hundredth. Shatis.
31.71.
Yeah. 31.71 feet. Alright, any questions? Alright. Law of cosines. Law of cosines. You're going to use law of cosines when you have a known side angle side combination, or all three sides are known. And they've got three different laws. All you need to know is just know one of these. Okay, you don't need to know. It's just a squared equals b squared plus c squared minus 2bc cosine of a. So if your square, if the side A is what you're finding, then you have to do the cosine of the angle opposite of it. If you set it up like that, then you're okay. So I would just memorize the top one. Okay. The derivation of law of cosines is similar to the law of sines. We're not going to take the time to do that. But here's an example on the next page of when you use siding. We have a side included angle and a side are known. I don't have a figure 8, so I'm going to use law of cosines. So I write the equation. A squared equals b squared plus c squared minus 2bc cosine of a. And then we plug in, so we have a squared equals, we plug in, so we have 6 squared plus 7 squared minus 2 times 6 times 7 times the cosine of 30 degrees. So then we plug in and we get a squared equals 36 plus 49 minus, you calculate that value, you should get 72.7461. So then we get a squared equals 12.2539, and then we take the square root, so a equals the square root of 3.5. Not the square root, a equals 3.5. The square root of a equals 3.5 is what I should have said. Alright. Any questions? Does everybody have that written down? Alright, let's do another one. So we have an awning kit. Comes with identical sets of 3 metal rods to be assembled at points A, B, and C as shown. If the wall mount rod is 3 feet long, the support rod is 2.08, and the attached foot is 2.34, so from A to B is 2.43. What angle would the awning make with the wall? Alright, so the awning is this is the awning. We have to know what angle it makes with the wall. This angle. Okay? So let's call that angle, well, that's angle A, right? So I write my equation for law of, I know I have 3 known sides, right? Don't know any angles, so I can't use law of sines. I have 3 known sides, so it's going to be a squared equals b squared plus c squared minus 2bc cosine of A. Then we plug in, and okay, so if we're trying to find angle A, then the side that I used to plug in for a squared here has got to be the one opposite of it. So we're going to use a 2.08. So we've got 2.08 squared equals 3 squared plus 2.43 squared minus 2 times 3 times 2.43 times the cosine of A. So now I have to solve for the cosine of A. So to solve for the cosine of A, I would have 2.08 squared, and then we subtract the other two, so we have minus 3 squared minus 2.43 squared, and we're going to divide that by, what would I divide it by? Yes.
2 times 3 times 2.4.
Okay, I asked that specifically because you have to divide it by negative. Don't forget the negative. It's negative 2.2 times 3. 2 times 3 times 2.43. Because of right here, this negative sign right there, There's your negative sign. So I probably should have had it down here. Let's move it down here. There's the negative sign, right? So you've got to divide by this to get cosine of A by itself. So it's going to be negative. And then, so that's going to be a negative divided by a negative. The top, when you subtract those other two, it's always going to be a negative number. So it's going to be a negative divided by a negative, so that makes it positive. So then you do cosine, so then you can do this on your calculator you can do it all at once. You can do cosine -1 of this value right here, but you got to make sure you have the parentheses correct, right? So let me put it on the board. If I enter this in my calculator, my graphing calculator, I would have, so I do cosine -1, and then parentheses, and then I would need another parenthesis, and then I would do 2.08 raised to the second minus 3 raised to 3 squared raised, and then minus 2.43 squared in parentheses. Then I would do divide, and then I would put parentheses -2 times 3 times 2.43 in parentheses, in parentheses. You have to do the double parentheses because if you don't put this in parentheses, it would just divide by 2, then it would multiply everything else by these two numbers. So that has to be grouped together, and likewise this has to be grouped together. If you don't group these together, then it would just take this 2.43 and divide it by that. So see if you can do that on your calculator. I'll tell you the answer you should get. The answer that you should get is A is equal to 43.5 degrees. That's what you should get.
Is this rounded to the nearest tenth?
Yeah, I rounded it to the nearest tenth.
Okay.
Now, if you don't have a graphing calculator, you may need to just calculate this number, right? You would calculate that number, and that you should get cosine of A. You'd get cosine of A is equal to 0.7255, right? And then you do inverse cosine. You do cosine -1 of 0.7255. You should get 43.5. Anybody wasn't able to get 43.5? I'll look at your calculator, see what you did wrong. Everybody got 43.5. Okay, very good. Okay, well that's the notes for today. Are there any questions on law of sines or law of cosines? All right, that's it.